Let's look at the two functions we have here. One is the eye color as a function of the student's name. So we've got Amy, Ben, and Chuck. And we associate to each student the color of his eyes. So Amy has blue eyes, Ben also blue eyes, and Chuck has brown eyes. And so notice that this is a function, right? Because from Amy, Ben, and Chuck, there's a single arrow leaving, right? There's a single eye color per student. And then Amy, Ben, and Chuck, in the other function, they're associated to their student's ID. So the student's ID is a function of the name of the student, hopefully, right? So you all have a single unique student ID. Otherwise, if you didn't, that probably would create problems at school. There's a difference between these two functions, however. In the second case, for a student ID, there's a single arrow arriving to it. Okay, so there's a single arrow, of course, leaving from Amy, Ben, and Chuck because it's a function. But where it's sent, that value is unique. There isn't another student that's going to have the same student ID, which is not the case with the eye color function because the blue eye color is associated with to both Amy and Ben. So if we try to look if the student name is a function of the eye color, that's not true. However, if we try to see if the student's name is a function of the student ID, that's true. So this is still a function. So in other words, I could also have the function student ID and student's name, and that would still be a function. So the student ID 95 1248 is going to be associated with Amy. Okay, and the number 95 1256, that's going to be associated with Chuck. And 96 1801, that's going to be associated to Ben. Okay. So when this is possible, when the you can also write the input as a function of the output of the initial input, initial output. Okay, so you can essentially reverse the function. It's called a one-to-one function, and that other function is going to be called the inverse function. Let's write this down here. So the second example is a one-to-one function. Okay, since the student's name is also a function of the student ID. This other function is called the inverse function. So let's see algebraically if we can tell if a function is one-to-one or not. So let's say I look at f of x equals x minus 1. Okay. If I think about the graph of this function, I could say y equals x minus 1. So obviously y is a function of x. So the question is, if this function is one-to-one, x could also be a function of y. So that's the question we're trying to answer. Is x a function of y as well? Well, that means, okay, can we solve for y the equation y equals x minus 1? Can we solve that equation for y? So obviously here, this is not too hard. So yes, okay? So this means that f is 1 to 1. Okay, so for a single, if I tell you what y is, you can tell me exactly what x is. Okay? So graphically, what do we have here? Maybe I can show you how we can determine graphically if you've got a function that's 1 to 1. Okay, let me first graph. I'm going to graph y equals x minus 1. Okay, this is the graph of a line, slope 1, y-intercept minus 1. So it looks like that. Okay. Now, first of all, it's clearly a function. It satisfies the vertical line test. Okay, so no problem. But we knew that already because we can the equation is already solved for y. So that means for a given x, there's a single value of y. The question is, for a given y, is there a single value of x? This is how we can tell if we've got a one-to-one function. So give me a value of y, is there a single value of x? In this case, we're going to draw a horizontal line. And if we intersect the graph in only one place each time, for each value of y given, okay, it's a one-to-one function. So I'm going to write this. If the graph intersects any horizontal line, in only one place, okay, maybe I should say at most in only one place, okay, then the function is 1 to 1. Okay, so this is called the horizontal line test. Algebraically, if you can solve for x, the equation y equals f of x. If you can solve for x, you've got a function. Let's look at another example where you've got f of x equals x squared minus 4x. Okay. Can we solve for x? Okay. Can we solve y equals x squared minus 4x for x? If we can, that would make that a one-to-one function. Now, if I try to do that, I don't know, I seem I get stuck. If I send 4x on the other side, you know, I could take square roots, but you know, I'm still I don't have only y on the other side. I have got x still, that's still there. In addition, I would have like plus or minus here, two possible roots, but the problem is I've got x already that's still there, so it seems like I'm kind of stuck. And same idea if I try to if I send the x, you know, 4x there, and send y on this side and divide by 4. I've not solved for x because once again I still have x there over here. So seems like I cannot do it. Will that be confirmed graphically? Well, let's look at it. Let's look at the graph of this function. So best way is to factor it. It's a quadratic. So we know what the x-intercepts are going to be, 0 and 4. The y-intercept is 0. It's concave up because the coefficient in front of x squared is positive. And its vertex is going to be halfway between 0 and 4, so at 2. So it's going to look like this, okay? So in fact, if you do the calculations, this is going to be 2 minus 4. So 0, 0, 4, 0. So we've got all the important points. But what's important to notice is that it fails the horizontal line test almost everywhere except at the vertex. So at the vertex, we intersect the graph in only one place, but otherwise, for all the other horizontal lines, we intersect the graph in multiple places. So there are multiple x values for a given y value, and that's the problem. So that's why it's not one-to-one. Okay, so this is not a one-to-one function, and that's why we couldn't solve it out. We couldn't solve the equation for x because it was not possible. It's not possible. If you could have done it, then that means the graph would not have would have succeeded the horizontal line test, but it doesn't. This is not a one-to-one function. Okay.